Okay, so this is example 6 according to our bookkeeping, and it goes like this. We need to evaluate the following integral. So we are still in case 3. It's 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 dx. So we need to solve it. The first thing we see that this is not a proper, the integrand is not a proper rational function, because the degree of the numerator and the degree of the denominator is, are equal. And we need the degree of the numerator be less than the degree of the denominator. So, we have the following. The integrand, let's write a comment here. The integrand is not a proper rational function. So we'll do long division here. So 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3 basically give us 1, because we have 4x squared and 4x squared. So we subtract 4x squared minus 4x plus 3, and we get the remainder. Negative 3x positive 4x gives you x, and then 2 minus 3 gives you negative 1. So we have plus x minus 1 over 4x squared minus 4x plus 3. Okay. A student in the honor class pointed out that we can actually, if we look at this, and we have negative 3x and we have negative 4x in the denominator, we have positive 2 and positive 3. He said, how about we'll add and subtract, we'll add negative x plus 1 and subtract negative x plus 1, and therefore we have 1 plus what we subtracted. When, if you do so, you end up having the same result. But this is something you can do if the degree of the numerator and the degree of the denominator are the same. Okay, but the long division is a fairly simple technique, so you can use that. And let's proceed from here. Okay, can I move on? All right, so now we're going to say that at this point we end up having the following. We're going to say that 4x, okay, we want to come up with a quadratic component factor in the denominator, and we'll complete the square. So let's write it here. And if you were ever exposed to this technique, it will come out to you in a hurry. It will come back to you in a hurry. Well, think about it. 4x squared minus 4x. And what do I need to add here to make it a perfect square? Okay. What am I missing here? If I write plus something here, and of course I need to subtract it too. Okay, I'm going to add and subtract something, and then I'll keep the 3. 8 is incorrect. 4 is incorrect. 2 is incorrect. 1 is correct. Because, so I need to add and subtract 1, because what is this? This will be 2x minus 1 squared. Remember, you need to add a perfect square. So 2, it rules out 8 and 2. Whatever you have, the last term of the trinomial, right here, you're looking at this trinomial. If this trinomial is a perfect square binomial, the first and last term have to be perfect square. So that's why 2 and 8 are not a possible number. 1 and 4, yeah, you may consider that, but 4 won't do it, because 4 is 2 squared, And 1 is 1 squared, and this will work out because you have 2, the square of 2x is 4x squared. All right, so what happens if at the end of the day you have 2x minus 1 squared plus 2? Okay, so now we have the denominator going to look like this. I'm going to bring it back in a second. And then you have x squared minus x. It won't work because the perfect square trinomial, you have a squared plus 2ab plus b squared. So you need, the middle term has to be twice of the first term. So if you factor 4, you have x squared plus x, or x squared minus x, won't work. Okay? And the only one that works in this case will be 2x squared, because 2 times 2 is 4. Anyway, this is the what we have now. So we can say that the numerator 4x squared minus 4x plus 3 is really the quadratic term 2x squared plus 2. Okay? And I want it to be u squared plus 2 in the denominator. So this is the quadratic term right now that I'm working on. So where u is 2x minus 1 and du equals 2 dx, right? So let's see. I lost my place here, so let me... I'll work on example 6, right? I'm back in place. I'm going to need also x 2, because I remember the numerator is x minus 1. So x will be, if I solve for x, then 2x equals u plus 1, and x equals 1/2 u plus 1, like so. Now go back to the original and see what happened after the substitution. Remember, we started with 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 dx. And after the long division, we end up having 1 plus x minus 1 over 2x minus 1 squared plus 2, like so. And now after inserting u, first of all, I have the integral of dx, and then I have the integral of this thing, okay? And x minus 1, since x is 1/2 u plus 1, then x minus 1 will be 1/2 u plus 1 for x minus 1, like so. And here I have u squared plus 2. And instead of dx, remember I have dx is du over 2, so I'll have du over 2, like so. There is a little bookkeeping that you need to maintain here. Let me bring back the previous page so you'll see the whole picture together, the progression. Okay. Again, this is where we started. We did long division. We came up with x minus 1 over 4x squared minus 4x plus 3. We completed the square, and we realized that the denominator is 2x minus 1 squared plus 2. We call this as, we substitute 2x minus 1 as u, and we end up having u squared plus 2. And x minus 1 becomes 1/2 u plus 1 minus 1, and the x is the u over 2 from here. Okay? And now let's do a little bit of clearing up. First of all, the integral of the x is x, so we can take care of this. And here we have the integral of 1/2 u plus 1/2 minus 1. So I'm going to just skip that last part and I say this is the same as 1/2 u minus 1/2. Okay, erase this one. Again, 1/2 minus 1 is negative 1/2. The denominator, I have 1/2 up front from du over 2, and the denominator is still u squared plus 2. So we have the u here, and now I can see that I can factor the 1/2, and I have 1/4, the integral of u minus 1 over u squared plus 2 du. Okay? One more step to take is break down this integral as the integral of u over u squared plus 2, and then negative 1, the integral of negative 1 over u squared plus 2, something that we already have done before in the previous example. So we end up having x plus 1/4 the integral of u over u squared plus 2 du, and then minus 1/4 the integral of 1 over u squared plus 2 du. So what is the result of the integration? The result of this integration, if again we've done this, if we had 2u over u squared plus 2, then we'll have simply the natural log of u squared plus 2. So because we don't have 2u, we have only 1, then we have 1/2 of the natural log. This is basically what we did before in the previous example. So we have 1/2 times 1/4, we have 1/8 natural log of u squared plus 2, and u squared plus 2 cannot be negative, so I don't need the absolute value. U squared plus 1 gives me the absolute value, gives me the inverse tangent. Let me rephrase that. The integral of 1 over u squared plus 1 will give me the inverse tangent of u. But 2 is the square root of 2 squared, right? And we end up having negative 1 over 4 square root of 2, and the inverse tangent of u over square root of 2. And I probably need to go ahead and explain that, and then plus c here. We didn't use a, b, and c, so plus c. And finally, let's bring home x. So x plus 1/8 natural log. U squared plus 2, if you remember, it's exactly the denominator of the integrand. You see it from here. So it's the natural log of 4x squared minus 4x plus 3, like so. And we already established the fact that it's going to be positive. And then here we'll have minus 1 over 4 square root of 2, the inverse tangent of, instead of u, I have 2x minus 1 over square root of 2, like so, plus c. So I probably owe you an explanation about this last integral right there. Okay, the integral of 1 over u squared plus 2 du. Okay, what I'll do here, remember how I did it before. I let u squared plus 2 I'll factor out the 2, and I have u squared over 2 plus 1, like so, but I need something squared, so it will be 2 u over square root of 2 squared plus 1, like so. Okay? This is how we get something squared plus 1. So I'll say this is equal, let's say 2w squared plus 1. Okay, where w is now u over square root of 2, and therefore dw equals du over square root of 2, or du equals square root of 2 dw. Okay, because we're going to need du, and therefore u squared plus 2 is 2 w squared plus 1, and now we're going to say that I, the integral, is the following. Instead of we have 1 over 2 w squared plus 1, like so, and then times square root of 2 dw, and factor out the square root of 2 over 2, and get the integral of 1 over w squared plus 1 dw. This integral is the inverse tangent, right? Square root of 2 over 2, if you, it's the same as 1 over square root of 2, so it will be 1 over square root of 2, the inverse tangent of w, and w is u over square root of 2, so you end up having 1 over square root of 2, the inverse tangent of u over square root of 2. And of course, the only thing left is to multiply it by 4. Okay? This is something that actually you can generalize it a little bit as well. Let me see how you remember where we started. We started with completing the square. So you can say that in general, the integral of a quadratic factor has a pattern. The integral of, let's say, ax plus b over ax squared plus bx plus c going to be c times the integral of u over u squared plus a squared du plus d times the integral of 1 over u squared plus a squared du. Okay? Notice we obtained this result twice in the exercise, in example 5 and example 6. This has always happened. How we obtained that? Well, we obtained the u squared plus a squared by completing the square. Okay? So actually, I need to write it here. Complete the square to get u squared plus a squared. So I don't need to mark it here. And now the antiderivative of the result of the integration, okay, will be, the first one will give you 1/2 the natural log of u squared plus a squared. So here's the general result. Okay, it will be c over 2, the natural log of u squared plus a squared. And this will give you the inverse tangent. So it will be d over 2a. Remember, a squared, in our case, a squared was 2, so 2a was 2 times square root of 2. And the inverse tangent of u over a, like so, plus some constant, let's call it k, because I have c and d already. Okay. So this is something that you can, every time you integrate a quadratic factor, you expect this to be the answer, the result of the integration. Go ahead.